Today's topic is conductance in electrolytic solutions. Now in this first slide I've taken a very simple diagram, very simple to understand. In fact, हमारे सामने तीन electrolytic cells है. In the first cell the substance taken is ethanol, thus no conductivity. Ethanol is a non-electrolyte. As you can see, the bulb here is not lit. In the second one we have taken KCl, which is an electrolyte and it is a strong electrolyte. In the third one we have taken an electrolyte, acetic acid, but it is a weak electrolyte. Thus we have high conductivity in the second one, we have low conductivity in the third one. You can see by the brightness of bulbs, this is a little dim, this is the brightest of the three, and this is not at all lit because the substance present is a non-electrolyte. So this is a basic concept. We understand what electrolytes are. We'll talk about electrolytes and non-electrolytes, then what a strong electrolyte is, what a weak electrolyte is. So obviously when you understand that, most of it you know already, we will easily understand conductance in electrolytic solutions. जितनी भी हमने अभी तक examples की electrolysis की, how conductance takes place in those electrolytic solutions. But first of all, let's do a general introduction of conductors. Solid state maybe we studied that solids are broadly classified into conductors, insulators and semiconductors. Now conductors वो solids है जिनमें there is the conduction either due to the movement of electrons or due to the movement of ions. That is why they conduct electricity. Now broadly classifying, these conductors are of two types: electronic conductors or electrolytic conductors. This is our concern right now, but let's go through the important points of both of them. The first one, these electronic conductors, they conduct electricity without undergoing decomposition. कोई decomposition उस substance में नहीं होगा. We'll see फिर conduction कैसे होता है. Whereas on passage of current, these undergo decomposition. जो अभी तक आपने सारी examples की, जैसे आप solution of electrolyte लोगे, they decompose into cations and anions. On this side, then conduction is due to the flow of electrons. You have studied the electron C model of metals. उसमें kernels होते हैं and there are mobile electrons. The flow of those electrons causes conduction. That is why the name electronic conductors. And वो free electrons, इसमें जो maximum examples है metals की है, that is why these conductors are also known as metallic conductors. And the flow of electricity is due to the flow of electrons. Now on the other side, the flow of electricity is due to the movement of ions. That is why they are electrolytic conductors. The third point is very important and you have to remember this, that in electronic conductors, conduction decreases with increase in temperature. What is the reason? You will have to again visualize that electron C model of metals, that जब हम increase करेंगे temperature, kernels start vibrating. They vibrate so much that they cause a hindrance in the movement of the electrons. What is conduction in these? Conduction is due to the flow of electrons, and anything causing hindrance will slow down the conduction. Thus when we increase temperature, vibration of kernels increases, hindrance increases, slowing down the movement of electrons, because of which conduction decreases with increase in temperature. On the other side, the relationship is very simple. Conduction increases with increase in temperature, because when we increase temperature, decomposition of the electrolyte will increase, movement of ions will increase, thus conduction increases. Now conductivity का opposite होता है resistance. Resistance by metal is due to vibrating kernels, as we studied here. जितनी भी resistance कोई metal show करेगा, it depends on kernels, positively charged metal ions कितना vibrate कर रहे हैं. More the vibration of those kernels, more is the resistance by that metal. On the other hand, resistance अगर show करेगा electrolytic solution, it will be because of interionic attractions. See in this diagram, it's a small diagram, लेकिन आपने बहुत examples किए हैं, you will be able to understand it. When we take the electrolyte in the aqueous state, या molten state maybe, we have cations and anions. Now they have to move, then only there will be conduction. If there are interionic attractions, आपस में ions के attractions होंगी, obviously it will slow down their movement. Slow down in movement leads to resistance. right? And viscosity of the solvent also leads to resistance, which is understood. You understand, you know what is viscosity. Jitna thick aapka solvent hoga, utna movement of ions will be difficult. That is why that leads to resistance. Examples are metals in this case. Graphite is a non-metal, it's an allotrope of carbon, but you know the structure of graphite. Each carbon atom is linked to only 3 other carbon atoms, adjacent carbon atoms, leaving 1 electron of each carbon atom free to move. Since it has free electrons, it can conduct electricity and it's an electronic conductor. And some minerals. I have added a very simple example of copper wire, which is an electronic conductor. In this case, electrolytes, right? This is a simple diagram जो आपने बहुत सारी examples करेंगे पिछली कुछ presentations में. Now you can describe the whole thing in terms of conductivity also. जैसे conductors दो types के हैं, electronic conductors and electrolytic conductors. You can describe in terms of conductivity. It is either metallic conductivity or electrolytic conductivity. This slide में the points of difference are more or less the same. Just a few additional points. That is why I added this picture. Electron current flows by moment of electrons. We already know this. Electron current flows by moment of ions. No chemical change occurs here. One important point again. Metallic conduction mein there is movement of electrons, but there is no chemical change. Whereas in electrolytes, you saw that in electrolytic conduction, in an electrolytic cell, oxidation takes place at anode and reduction takes place at cathode. Thus there are chemical changes. Does not involve any transfer of matter. We have transfer of matter here from one part of the cell to another. Ohm's law is followed by both. What is Ohm's law? We'll do it in the next presentation. Now resistance increases with increase in temperature, as I told you previously, because vibration of kernels increases. In this case, resistance will decrease with increase of temperature, because when you will increase temperature, you will improve the moment of ions, resistance will be decreased. Don't get confused between these two points. This is conduction. ये decrease और increase हमने describe किया है in terms of conduction, and यहाँ पे it is in terms of resistance. Resistance is an opposite of conduction. Okay, again one more important point. Faraday's law is not followed here. In metallic conductivity, Faraday's law is not followed. Faraday's law you did yesterday, which is a quantitative relationship between W and Q, amount of electricity passed and the amount of substance deposited on the electrode. The law is not followed in this case, whereas in electrolytic conductivity, Faraday's laws are followed. Right? Now, since we have to do electrolytic conductors mainly, our main concern is electrolytic conductivity, and it is shown by electrolytes. Our next point of discussion is electrolytes होते क्या है. Broadly हम classify करते हैं substances को into electrolytes and non-electrolytes. As I said, non-electrolytes are substances which do not dissociate into ions in their aqueous solutions, whereas electrolytes जैसे भी आप dissolve करोगे in this solvent, they dissociate. The first thing that happens is they dissociate into cations and anions. We have done this classification in class 11th. That is why मैंने elaborate presentation इसका बनाया नहीं है. This is a very simple concept. Now when you have electrolytes, those electrolytes can be strong electrolytes, they can be weak electrolytes. You know that it's a strong electrolyte if it dissociates completely, and it is a weak electrolyte if it undergoes partial dissociation, right? We have examples on this side. Now strong electrolytes may, it can be a strong acid, it can be a strong base, it can be a salt. Weak electrolytes may, it can be a weak acid, it can be a weak base. I have taken a few examples on this side. Acids produce H positive. By definition, acid chahe strong ho ya weak ho, it's a substance that produces H positive when dissolved in water. Now HCl is a strong acid, thus a strong electrolyte. Dissociates completely, that is why this arrow into H positive and Cl negative. HNO2 is a weak acid. जब आप पानी में dissolve करोगे, thus these arrows dissolves into H plus and NO2 negative. H2SO4 is a strong acid, dissolves, completely dissociates into H positive and SO4 2 negative. Base, it can be a strong base, it can be a weak base. By definition, base will consume, it will take up H positive. There are so many concepts, we are not going into that right now. We are using the basic definitions. Sodium hydroxide is a strong base, thus a strong electrolyte. Therefore, this arrow, it dissociates into Na plus and OH negative. Right? Here we have used water. No, OH negative from any source of base, OH negative, and it takes up H positive, forms H2O. It can be any base. The weak base we have taken is NH3. In aqueous solution, it takes up H positive and gives us NH4 positive. Thus the arrow, because it is weak. Double-headed arrow, jis bhi example mein hai, it's a weak acid or a weak base because they undergo partial dissociation. That is why they are weak electrolytes. And salts, which are strong electrolytes, they undergo complete ionization because they are strong electrolytes. Right? Now in this slide I have taken these two examples again. I explained to you the first one. We have a non-electrolyte here completely. There is zero conduction. The bulb is not lit. Second one, we have one of these, one of the strong electrolytes. Therefore the bulb is lit and it is bright. And here we have one of these weak electrolytes. That is why there is conduction, but not as good as the second one. Bulb is lit but it is dim. The second one, we have metals. This is metallic conduction and the conductivity values are given here. Silver इनमें सबसे ज़्यादा, then copper, then gold, then iron, then aluminium. All of them undergo metallic conduction. That is, they conduct electricity because of the moment of mobile electrons. Right? I've taken more examples here just to clear the concept. In this diagram, in both of them there's an electrolyte, but we have a strong electrolyte here and we have a weak electrolyte here. That is why in both the cases the bulb is lit, but it is brighter in this case and it's a little dim in this case. However, look at these two diagrams. These two diagrams are very important. In one cell there is water with impurities, in the other there is distilled water. I told you in previous presentations also that pure water is a poor conductor of electricity. You know, there is no ionization. The rate of ionization is so slow that pure water ki in fact hum electrolysis kar hi nahi sakte. As you can see, the bulb is not lit in case of distilled water. It is lit when you take water with impurities. Similarly, this is pure water and this is water with sodium chloride. There is Na plus and Cl negative. Due to the movement of those ions, the bulb is lit. There is conduction of electricity. Right? Now what are we doing? We're doing conduction. We haven't moved to the elaborate electrolytic conduction yet. In this presentation we have just done the general introduction of conduction and the difference between electrolytic conduction and metallic conduction. Let us see what are the factors affecting this conduction. First, we'll take up factors affecting electrolytic conduction. Nature of the electrolyte. Very important first. As in this diagram, what is the nature of the electrolyte? One, it is not an electrolyte. In the other two, it depends कि आप strong electrolyte ले रहे हो, weak electrolyte ले रहे हो. So, how does it affect? Strong electrolytes ionize completely. Thus, stronger the electrolyte, greater is the conduction. Weaker the electrolyte which will ionize partially or partly, there will be a small extent of electricity. Second, again, size of ion and its solvation. Solvation hota hai when it mixes with the molecules of the solvent. Now, greater the size of the ion or solvation, less is the conductance. In spite of the fact, अगर ये electrolyte है, फिर strong electrolyte भी है, अगर इसका size बड़ा है और solvation ज़्यादा होती है, conductance will decrease. It will have a decreasing effect on its conductance. Nature of the solvent and viscosity. Electrolyte ionizes more in polar solvent. अगर आप electrolyte ले रहे हो लेकिन solvent polar ही लेते हैं mostly, जितना polar आपका solvent होगा उतनी उसकी conductivity बढ़ेगी. And viscosity has a reverse effect on conductivity. More the viscosity, more viscous the solvent, lesser will be the conductivity. Obviously, because electrolytic conductivity में conductivity is because of the movement of ions. If the solvent is viscous, it restricts the movement of ions. When the movement of ions is restricted, it leads to the decrease in conductance, right? Electrolyte ionizes more in polar solvent. This is about the solvent. The last point, greater the viscosity of the solvent, less is the conductance. Fourth, concentration of solution. Higher the concentration, less is the conductance. The reason is very important, again this point. The reason is that when there is more concentration, what happens? There is a large number of ions. A large number of ions is produced in the solution phase, because of which there are interionic interactions. When interionic attractions increase, movement will be restricted. So जितना ज़्यादा concentration होगा, जितना ज़्यादा number of ions होगा, उतनी ज़्यादा interionic attractions होंगी. Movement of ions which would lead to conductance is restricted. Thus, higher the concentration, less is the conductance. Temperature, we're talking about electrolytic conduction. I already told you that on increase in temperature, there will be increase in dissociation, increase in the moment of ions, therefore conduction increases. All these points are very, very important. Then factors affecting metallic or electronic conductance. There are just three factors: nature and structure of the metal. We have here in this diagram different metals and different conductivities. Obviously it depends on the number of mobile electrons and how whether there is lesser resistance of the kernels or not. So depending on the nature of the metal, conductance will be different. Nature and structure of the metal. Number of valence electrons. Obviously everything is based on the electrons. Conductivity is there due to the movement of electrons. So कितने valence electrons होंगे, कितनी movement possible है, that will directly affect the conductance of the metallic conductor. Temperature, the last point, very important again. It decreases with increase in temperature. I'll repeat it one more time because it's very important. Why? When you increase temperature, kernels start vibrating very fast and they cause a hindrance in the movement of electrons. Their conduction is due to the movement of electrons. When there is hindrance in the movement of electrons due to the increase in temperature, conductivity or conductance will decrease, right?